3, 2, 1.
In 2012, Zhong Changyu left his job as an engineer at a company called ASML, the only company in the world that can make this machine. This machine makes the most advanced semiconductor chips or microchips in the world. After he left ASML, he started 2 new companies, one in the US and one in China. US and ASML lawyers would later allege that you recruited other ASML engineers to his US company, that they brought with them stolen information about ASML's machine, and that it was all backed by the Chinese government. This story is just one small piece of China's monumental effort to transform one of the world's most global and significant industries, semiconductors. But China's effort has increasingly locked it in a struggle with the United States. So, how exactly did China and the US enter into a Cold War over computer chips? This is the first semiconductor chip invented in the 1950s by engineers in the US. It's a piece of silicon with 4 transistors on it. The more transistors, the more powerful the chip. By 1960, engineers had already made one with 4 times the transistors, and each year they figured out ways to add more. The first companies dedicated to making chips were in the US, where they really just had one main customer, the US government. Since chip companies were making better and better chips each year, the US government believed a deep partnership with them would ensure that it always had access to the most advanced ones. At first, these chip companies handled the entire supply chain. They designed the chips, manufactured them, and assembled them into a package for installation into a product, all within the US. But by the late 1960s, they realized they could make a lot more money designing chips for civilian products, like corporate computers. They just had to make a lot more of them, and a lot less expensively. So many chip companies moved their manufacturing and assembly to factories in Japan, Taiwan, South Korea, and Hong Kong, where labor was cheaper and the US government encouraged them. All these countries were US allies or partners, and this was a way to support their economies and deepen ties. At the same time, it banned these chip companies from sharing technology with its rivals, the Soviet Union and China. It was a way to keep them years behind the US as chips advanced, but it wasn't long before these allied governments began investing in their own chip companies in the 1970s and 80s. Toshiba in Japan and Samsung in South Korea began designing and manufacturing chips that rivaled the Americans. And in the 1990s, the Taiwanese company TSMC got so good at manufacturing chips that many companies in the US stopped doing it. It meant that companies were not the only ones who could make the most advanced chips anymore. And every country's chip industry was increasingly reliant on other countries for the materials, software, and equipment needed to make more complex chips. But while the US and its allies were pushing the limits of chip technology, China was lagging behind. In addition to the US blocking it from accessing chips during the Cold War, many of China's brightest scientists and engineers have been driven out of the country by the dictator Mao Zedong during the 60s and 70s. But over the next few decades, new Chinese leaders pushed to catch up. By the 1990s, the Cold War was over. The US had become friendlier with China, and it had lifted most of its export controls. And so China enticed many chip companies to move their assembly operations to China, and by the 2000s China dominated this end of the supply chain. But China was importing more and more chips to feed its assembly industry, and it put them in a tricky position. So the Chinese government poured money into its own chip design and manufacturing companies, which increasingly partnered with non-Chinese firms, all in the hopes of creating a chip supply chain that existed entirely within China. Soon, China could design, manufacture, and assemble some older generations of chips, mostly on its own. But it was still years away from making the most cutting-edge chips. This is one of those chips. It's got around 114 billion transistors on it. Remember, in 1960, chips had 4. The problem is, only a few companies in the world are involved in making them, and none are in China. To start, only 3 American companies make the software needed to design advanced chips. Then turning those designs into real chips requires a machine that's only made by one company, ASML. But this machine requires equipment that's only made in the US. Finally, only companies in Taiwan and South Korea can put it all together and manufacture the most advanced processor chips. These companies are choke points in the supply chain, and China was totally reliant on them for advanced chips. In 2019, police and the US went to arrest Zhong Chengyu, but couldn't find him until he appeared later in China as the CEO of his company that successfully made software like TES-MEL. Thanks to help from the Chinese government, his company was flourishing, and his story was just one of several instances of IP theft in the chip industry. In order to eventually decrease its reliance on this foreign supply chain, China was identifying choke points like a SEM land, copying them. But the plan backfired. This was happening at the same time that the relationship between the US and China was becoming less cordial and more competitive. In 2018, the Trump administration banned US companies from selling components to ZTE, Chinese tech company. Then in 2019, it banned US companies from doing business with China's biggest tech company, Huawei, and its affiliates. These bans nearly bankrupted ZTE and dealt a significant blow to Huawei in 2022. The next US President Joe Biden targeted China's chip industry more broadly. First, it banned all US companies from selling advanced chips to China. But it also blocked Chinese design companies from using US-made design software and US-made manufacturing equipment. Plus, it banned global companies who use US semiconductor technology from selling advanced chips to China as well. The US was exploiting these choke points to stop China's chip industry in its tracks. Next, the US passed a law that would invest billions of dollars into its own chip manufacturing companies and finalize a deal with Taiwan's biggest manufacturer, TSMC, to build manufacturing plants in the US, all to enable the US to keep racing ahead. But this has also put extraordinary pressure on another conflict between the two countries. Since 1949, China has viewed Taiwan as a breakaway province and has vowed to reunite with it, even threatening invasion. The US has vowed to protect Taiwan, but Taiwan also happens to own the most important choke point in the chip supply chain. Taiwanese companies manufacture 63 of all chips and about 92 of all advanced chips, with companies that are indispensable to both the US and Chinese chip industries. Taiwan has built itself some protection, but the US export controls forced Taiwan's companies to make a choice: defy the US and keep selling to China, or comply and cut off China from some of its chips. So far, they've signaled they'll cut off China, but as China and the US feud over chips more and more, choices like these are going to be imposed on countries and companies around the world, asking them to pick sides in what looks a lot like a new Cold War. In 1959, the US was about to get very lucky. Computers at the time were becoming a thing, but they kind of looked like this. Tons of wires connecting everything, all of them sending little precise electronic signals to each other to solve tedious, complex math problems. It was clunky, it was inefficient, it wasn't very special yet. But then two American engineers that were working currently at two totally different companies had a very similar idea, and the idea was to get rid of this. All these wires, there was this new technology that had cropped up called the transistor. It was like a really precise, reliable on and off switch, allows you to control pulses of electricity super precisely. But first, transistors looked like this. They were big and clunky, lots of parts. So the idea was, what if we start carving these little on and off switches onto a material called silicon? It's like a super abundant metal-like material inside of Earth's crust, but it's actually a horrible conductor of electricity. If you mix silicon with other elements, it conducts electricity really well. It is a semiconductor of electricity, exactly what they needed to precisely control the flow of electricity very accurately. No more clunky long wires. Let's just carve our little transistor switches onto the silicon chip, a single circuit. That way we can fit a lot more into one place, all close together, so transistors can turn on and off and they send a signal that results in one of two things, a 1 or a 0 when it gets to the other side. Super boring and useless if you just have one little transistor sending a 1 or a 0. But if you have 1,000 of these switches all sending little signals in the right order, suddenly you have something that kind of resembles a little brain firing signals and a coordinated system that can actually solve logical mathematical problems and literally remember things. This is kind of how our brain works. It's pulses, lots of pulses. And now we're talking about computing. This is how computers work. It's the more pulses of electricity you can control, the more you can do with technology. And suddenly, there's a new gold rush in the United States. But the gold is now silicon, and the rush is to put as many of these little switches onto that silicon chip as possible so that we can make our technology do more and more sophisticated stuff. And now people have smarter clocks and TVs and radios and video games and calculators. Things that you can hold in your hand and press a bunch of buttons, and suddenly the silicon chip is solving math problems for you. Instantaneously. The US military and NASA are first in line to get their hands on these new chips. They dream of using them for more sophisticated weapons or going to the moon. Chips were becoming a currency for national power. We've got to protect them, thinks the USA. Luckily, the USA didn't really have to do much to protect them at first. They were killing it. They were the global leaders of this chip-making stuff. Every year, US companies crammed more and more transistors onto this little piece of silicon. More calculations per second. More and more companies are now cropping up to make dreams come true with their new magical microchips. Lots of this action was happening right here in Central California, in a valley that would soon take on the name of the material that enabled all this magic to happen. By the mid-1980s, they were carving nearly 300,000 little on and off switches onto a piece of silicon. Oh, and look, it's Steve Jobs and Bill Gates. Home computing, color televisions, more advanced satellites, and smaller electronic devices of all kinds. There's a revolution happening, and over the next 30 years the number of transistors that they can fit onto a piece of silicon starts to become ridiculous. And it's like the 90s, and these things are getting faster and smaller. And now humans have computers in their homes that are more advanced than the ones that were used to land on the moon. And look, it's even smaller now. It fits in your pocket. None of this is possible without these little magical brains made of silicon.